Hello, everyone, and thank you for joining us today. We know you are very busy, and we really appreciate you taking the time to spend the next 45 to 60 minutes with us. Today's webinar is called Introducing the Machine Learning Workbench, a better way to build graph neural networks, and we hope you find it interesting and informative. Next slide. Cool. So my name is David Ronald. I'm Director of Product Marketing at TigerGraph, and I'll be your host. And I am delighted to introduce two esteemed colleagues to you, Andrew Wei and Bill Shi, who will lead you through today's webinar. Andrew is the Principal Product Manager for Machine Learning Solutions at TigerGraph. Andrew graduated with an MS in Computer Science from Tsinghua University, where he was focused on NLP. Prior to joining TigerGraph, Andrew worked on speech recognition, search ranking, and feed ranking at a variety of companies, including Microsoft, Intuit, and Facebook. And in his copious amounts of free time, that was a joke, by the way, he probably has very little free time. Andrew likes to scuba dive, do some photography, play some basketball, and fencing. Now, turning to Bill Shi. Bill is our Senior Machine Learning Solutions Architect. Bill has a PhD in applied math with a research focus on complex networks from UNC in Chapel Hill. Prior to joining TigerGraph, Bill led the social network analysis at the Carolina program at UNC Chapel Hill, and also led the book's Knowledge Graph Initiative and the Graph Machine Learning Research at Amazon. And then Bill has also been published in a variety of top academic journals, including Nature, Human Behavior, PNAS, Social Networks, and many others. So welcome, Andrew, and welcome, Bill. Next slide. So before we get started, just a few quick housekeeping items. Your device is muted, but that's not a sign that we don't want to hear from you. It's quite the opposite. We'd like this session to be as interactive as possible. We're doing this for your benefit. So, by you submitting questions to us, we can help make it more interactive and make it more productive for you. So please, feel free to submit questions at any time. And best way to do that is through the Q&A tab in the Zoom menu at the bottom of your screen. Today's webinar is being recorded and will be emailed to you. My colleagues in marketing are very quick and typically can get the email out with the slides and any other materials that Andrew and Bill want to share within about 2 hours or so. So look for that email, later on today. And then last but not least, it's pretty rare these days. We can probably remove this final bullet, but if you do have any issues with Zoom, please contact me via the chat, and I'll do my best to address them. So with that, I'm happy to pass the webinar over to Andrew.
Well, thank you, David, for the introduction. Hello, everyone. My name is Andrew. Thank you for spending your valuable time here with us today. And also thank you for your interest in learning more about exploring GNNs with TigerGraph Machine Learning Workbench. So today we have the following items on the agenda. To start with, we will start at the very high level, describing what is graph data science and what kind of tasks or applications we can do with graph data science. What are the categories of algorithms one can use to answer a business question, for example. And then we will do an introduction on ML Workbench itself. What is it about? Who is it for? And how can it be useful for those who want to do graph native learning, such as developing a graph neural network model. We will then go over some of the key features and functionalities our product offers. We will then have my colleague here, Bill, to walk us through a Jupyter Notebook example to showcase how easily it is to develop a GNN model for real-world applications, such as detecting a fraud account on Ethereum. We will leave a few minutes to talk about how to get started with ML Workbench and where to find resources in case you get stuck. We will also have, we will reserve a few minutes at the end for Q&A. Okay, so I want to start our webinar today with an emphasis on what we do here at TigerGraph. Our mission is to empower professionals in all companies to unlock smarter insights at scale with speed via graph. And we want to democratize graph and want to build tools to make graph accessible and applicable for everyone. So the keyword I want to highlight here is unlock smarter insights and graph. With data being represented in a connected way, we can discover more useful information that would be meaningful to one's business by applying various data science techniques. With these new insights, one can maybe make a better business decision with better forecasting, for example, or maybe to optimize an existing product experience with better product recommendation or engagement prediction. So as mentioned earlier, what is graph data science? And how can it help to improve your business or application? Here in this slide, I want to first define the terms graph data science. It is the use of analytical techniques to uncover insights from connected data. So what are those analytical techniques? In this chart below, we want to categorize these techniques into the following categories, going from left to right, ranging from less complex, less complicated to a more complicated graph algorithm. One can write a simple n-hop queries on a graph database to discover how data is being connected, or you may run a graph algorithm such as PageRank, which otherwise not feasible to do it with the tabular data. So moving forwards to the right, from the left to right, we will get closer towards to a machine learning. A data scientist can choose to run a graph algorithm to generate unique features and feed them into, say, a traditional machine learning model to formulate a better prediction. Or you can use embeddings to do some kind of similarity measure. And finally, last but not the least, graph native learning. We have seen many papers published in the past few years calling for graph neural networks. It has been showing its success across many domains, and we have it has outperformed other cutting-edge traditional machine learning model. And this is also the focus of our webinar today, to talk about how you can use ML Workbench to bootstrap your graph native learning development journey. So to tie the graph data science back to an application level, I want to start with this toy example with Star Wars, since we're all coming from different industrial background, and I want to leverage Star Wars due to its popularity. So if we were to organize Star Wars characters and stories into a graph data set, finding out who is the father of Luke Skywalker would be translated into a very simple n-hop queries, where the edge will indicate the relationship between two nodes, the characters. We can answer more complicated questions like who is the most important characters in the resistance, which would sound to me like running a PageRank. We can even do crazier stuff like help me generate an embedding representing the dark side, so that I can make a better decision on which side to join, for example. I don't know. Or moving forward more towards the inferential statistics, we can build a GNN model to predict, say, which planet Death Star is going to destroy next. And for those of you who do not believe Star Wars is a true story, I have a couple more real-world examples here. So, for example, finding the most cost-effective path for a truck delivery company, finding a community of patients to promote a drug, finding a protein molecule structure, whether it's toxic or not. These are all important real-world business applications that graph data science can help to answer. And as you can see, the more complex the analytical technique is, the more complex the business questions we can answer. Okay, so now we have this mental map of graph data science journey in mind. I want to do a quick recap on how our product offerings can help users in this journey. Now, to start with, we need the right platform as the foundation to persist the graph data. TigerGraph database being the distributed MPP or massive parallel processing database engine that can handle terabytes of data, being able to execute graph queries in real time, And with the enterprise grade level security, we also have Graph Studio being the visual SDK to easily explore and manage your database. Next is the right query language. We have if you have written SQL previously, most likely you will be able to pick up GSQL very quickly due to its similarity to SQL. It is a Turing-complete query language. This means that it has the same expressive power as any other high-level language, where you can do if-else statements and for loops to describe an algorithm. Now, because the query language runs on our database, this means the built-in parallelism and accumulation so that your algorithm will run with speed. We also have Graph Data Science Library. You can think of it as your dictionary of graph algorithms. Currently, we have 55 plus algorithms published. They are open source so that you can see the logic behind each algorithm, and you have the freedom to further customize it based on your data structure. They are fast because these algorithms are run in database, leveraging our core engine. And finally, the topic of today, we recently made the preview release of Machine Learning Workbench, which would enable our users to develop supervised machine learning techniques such as GNN to do things like node prediction. It is fully integrated with the TigerGraph database, which means you can directly leverage TigerGraph as your data source and plug it into your existing machine learning pipeline and infrastructure. Excuse me. So to double click on the Graph Data Science Library itself, you can find our graph algorithms categorized into the following categories. You can find algorithms like doing shortest paths, or PageRank for centrality, Louvain for community detection, and so on. Now, the green categories are newly added in the past few months or so. They are more leaning towards machine learning. You can run topological link predictions. You can generate embeddings by running FastRP or Node2Vec, or you can do frequent pattern mining. Again, these algorithms are run inside our distributed core engine, so they are performant. You can run these algorithms individually, or you can stack them up to solve a more complex problem. Or you can run them to generate input features for your graph neural network. So in the second half of this webinar, we will have Bill to show us an actual example of how to run these algorithms to generate graph features and then train a graph neural network. Okay, so now I want to briefly touch on graph neural network if you're not already familiar with it. The reason GNN tends to outperform other traditional machine learning on a connected data set is because it learns directly on the graph's connectivity. This means the model is able to learn new insights from nodes and edges and aggregate or capture these useful information from a node's neighbor or neighbor's neighbor. GNN can be used to do vertex prediction type of tasks such as fraud detection or predicting a risk score, or it can be used for edge level prediction applications like recommendation system, feed content, or product recommendation. A graph level prediction could be an application like whether given a protein molecule, is this protein structure toxic or not, or maybe predict what is the next mutation of COVID would look like, which I hope there will be no more next mutation. So now we have established the usefulness of GNN and why it is so powerful. And I want to talk about the challenges today that that is before we introduce ML Workbench. We have seen research papers published by big companies like Facebook, Pinterest, Amazon, but a lot of times, many companies do not have this big research group like these big companies. Now, building GNN requires a high bar of entry. It requires one to be knowledgeable across several domains like deep learning, graph data science, and the ability to write good graph queries. The next challenge is building a toy example or doing academic research versus building an enterprise level application. It also presents different challenges. And our graph, and when our graph is at terabyte size or with hundreds of millions of edges, we will run into scaling problem. There's also a lack of integrated solution on the market today, connecting graph database, machine learning framework, and other cloud machine learning infrastructure. This means that, as a data scientist, I need to spend a lot of time to do manual, mundane tasks related to data engineering, data processing, manipulate my graph data. So all these challenges translate into longer R&D cycle and also slower speed to delivery. So ML Workbench. We designed ML Workbench having these challenges in mind. We want to build a product that can help democratize GNN development process. TigerGraph Machine Learning Workbench is a Jupyter-based Python development framework. It is designed for everyday data scientists use. Machine Learning Workbench is pre-packaged with Python libraries and built-in functions for graph data processing, manipulation, subgraph sampling, and data loading, so that our users can focus on the actual model development and do experimentation. ML Workbench is also compatible with the most popular machine learning frameworks such as PyTorch Geometric, DGL, and TensorFlow. Also, it is platform agnostic. So, if your data science team or your organization already have an ML pipeline running on clouds such as Amazon SageMaker, Google Vertex, or Microsoft Azure, Machine Learning Workbench can be plugged directly into your machine learning infrastructure. So the key benefit of using Machine Learning Workbench. Our ultimate goal is to bring value to your business, the user's business. With GNN being the most cutting edge machine learning technology, we want our users to have a bigger business impact with their graph data. We want to ensure your data science team to have an easy development experience. So we do the heavy lifting behind the scene to provide the most optimal graph traversal queries and built-in functionality for data preparation so that they can focus on the model development at the Python level. Machine Learning Workbench is designed to work together with your existing ML pipeline and infrastructure so that minimal effort is needed to get started. And finally, because ML Workbench is tightly integrated with TigerGraph database, this means our users will get the same benefit when it comes to database performance and scalability. So up next, we will have Bill here, who is our senior architect, to walk us through an example of how to easily create a GCN on Ether dataset to do fraud detection. So Bill, please take us away.
Bill, before you do that, Andrew, there was one question, well, two questions from one person in the audience, from Prabhu. The question is frequent pattern mining an example of unsupervised ML? If so, would you still have to feed it the pattern of interest?
The pattern will be mined automatically. It is an unsupervised machine learning algorithm.
All right, cool. And then another question just came in. Does ML Workbench incur additional license on top of existing enterprise license cost?
Yep. So for the preview right now, this is free. So there's no additional license cost. So please, go, if you have interest, go ahead and download it. It is already published in our main website. We will also provide the link in the presentation.
Great, thanks. Okay, Bill, over to you.
Right, thanks. Yeah, and thanks, Andrew, for the great introduction. So let me share my screen, and hopefully I can take you through the journey of GNN with our ML Workbench. All right, there we go. So if you cannot see my screen, feel free to type, in the window, in the chat window. So I assume you can. Now I will get started.
Yeah, we can see it, Bill. Looks good.
Thanks. Awesome. So, all right. So, this is what, what the ML Workbench looks like at the first glance, right? So the ML Workbench, as its name suggests, it's a workbench you can actually work on to develop your GNN models. And under the hood, or behind the scene, it's a JupyterLab, a customized JupyterLab built by TigerGraph. So, however, that doesn't mean you have to use JupyterLab for your development work. You can use Visual Studio Code or any other IDEs you like, but you do have to use Python, at least for now. At the end, I will show you, I will walk you through briefly how you can integrate our ML Workbench, our packages with existing ML infrastructure. But for now, yeah, let's get started. So what I'm going to demo today is about a fraud detection application of graph neural networks on cryptocurrency data. And the specific data set we're going to look at is the Ethereum transaction network, or graph. The data set is from this XBlock website or organization. Feel free to check it out if you're interested in the data itself. But here, I'm just going to give you a brief overview. So this is a transaction network, right, on the Ethereum platform, which is, I think, the second largest cryptocurrency platform. And then the vertices in the graph are wallets or accounts of the Ethereum platform or system. And then the edges are transactions between those wallets, right? It's very clean structure. All right, so I already have the data preloaded into a TigerGraph database. So I'm not going to show you how to ingest data. If you're interested in that, I think there are also another series of tutorials on ingesting data itself. So now we have the data preloaded. Let's take a quick peek at it. To do that, I think the best way is to, take advantage of our nice GUI interface to the database called Graph Studio. You can go to Graph Studio directly, but since we are on the ML Workbench, let's take the Workbench way. So on the ML Workbench, right, you will see a tiger icon on the left of your screen. That's our JupyterLab extension, and there you can add your TigerGraph database servers. So I already added mine. If you want to add yours, just click Add Server, fill out all this information, and then you're done. So now I've already added. So what I need to do is to click this Graph Studio button, and it will open Graph Studio on the browser, right? So Graph Studio, as I just mentioned, is the GUI interface to the database. So here you can do a lot of things about your graph data. So here I just want to quickly show you what the data set looks like in terms of its schema, right? So the data set, as I just said, the vertices or accounts or wallets. So that's the vertex here, or vertex schema here. And then the edges are transactions between the accounts. So that's the arrow you see from account to account. So this is a schema. And on this screen, you see another type of vertex, which is label. So I'm going to skip that, but I can just give you a quick explanation. So basically, the label vertices are extra labels of the fraudulent accounts we have crawled from somewhere else and added to the database later. So the origin data set, accounts, transactions, that's it. And another thing I want to show you is that you can quickly take a peek at your graph if you go to the Explore Graph section, right? And here, you can see, a few accounts here, a few vertices here, and you can see their IDs and their attributes. They have a lot of attributes. Cool. And then the last thing I want to show you is GSQL queries. right? And as Andrew said in his slides earlier, you can write GSQL queries to manipulate, to process your data. And here, this is a nice sort of IDE specifically for writing GSQL queries. I can show you one. So this is one query to calculate the amounts, the minimal and the maximal amounts of money, that every account has received or sent out. So this is what a typical query looks like, right? You define, query name as a function, and you define all the variables. And if you are familiar with SQL, you see this familiar syntax: select something from something else. The special thing here is that the from clause can be a graph traversal, right? It can be here you are going from one node to the other, and you can add any. I think with the new syntax, you can add any long, any steps of traversals. So I think I'm not going to, this is not a tutorial on GSQL. I think there's also an amazing series on that. So I just want to give you a quick pick. So basically, this is how we calculated some of the features, right? Like the amount of money each account receives sent out. Cool. So with that, let's go back to the ML Workbench. So that's what the data set looks like. All right. And with the data, there's one more step currently before you can actually write your Python code, which is to deploy the service called Graph Data Processing Service, GDPS for short. What this service does, is to serve as a middleman between the database and your Python code, so that you can do all kinds of data processing tasks with the database. We're trying to streamline and simplify the process, but for now you need to deploy that service to the TigerGraph database server. And the way to do that is actually very simple. It's better than it sounds. You just need to click this one-click install button here, GDPS, and then the service will be deployed to our TigerGraph data server. So I've already done that. So if I click it, I will get a prompt that the service is running there, so I'm fine. If you don't have a service running, then it will do the deployment for you or installation for you. All right, so now with all the infrastructure set up out of the way, we can finally start it coding our first GNN neural network with TigerGraph. To do that, of course, you need to import a bunch of libraries. I would like to note, right, 3 key libraries here. So the first one is TGML, which is our Python client for talking to the GDPS service and to the database. Right, so of course you need that. And then this tutorial, I'll be using PyTorch geometric for the actual graph neural network part or the modeling. So you need the PyTorch geometric library, of course. But our workbench also supports DGL. I think it stands for Deep Graph Library. So that if you're a DGL user, you're covered. In the very near future, we will also support TensorFlow. So right now, DGL, PyTorch geometric, no problem. Okay, the third library is for visualization. So we also have TensorBoard built into the workbench. So if you would like to see, who doesn't want to, the visual training status, then you can use TensorBoard out of the box. And you don't need TensorFlow installed for that. Okay, then the other libraries are kind of standard data science Python libraries. If you have been doing data science with Python, I think those will be your old friends. All right, so after the libraries, now the first thing we need to do is to create this object that stores all the information about your database. Right, so as you can see, what it needs are of course the IP address, of your database, the name of the graph, username, password. And here, for this demo, right, I have written down the passwords explicitly. But if you want to, if you use it for production or you care about, privacy, the package can also read from environment variables. So you don't need to note passwords here explicitly. You can just set it in your environment variable and it can read it. And of course, all this what I've said just now are in our documentations. So we will share that with you later. And then the final argument is whether you're using token authentication with a database or not. So that's an option you can turn on and off with a database. Right. So here, I have it turned on. Then this object, right, this TigerGraph object offers some convenience functions so that you can get some quick information about your data set. And here, one thing we care about here is the number of vertices, right? And you can see, that's the number of vertices. If you are familiar with that Ethereum data set I just noted above, you might note that here the number of vertices is smaller than the raw data set. That's because we have removed all the vertices with 0 degrees and 0 money received or sent out, because those things we think those vertices or those accounts won't play a role in the fraud detection effort. So after that, of course, we split the data set as a good practice, right? We split the data set into training and validation subsets. So that we will train our model on the training set and give a fair evaluation on the testing set, validation set. And here, we're just checking the number of vertices in each subset. That can be done by specifying a filter when you call the number of vertices function. The ML Workbench also offers a function to randomly split your data set, if that's all you need. For this data set, since it's temporal, right, we did the split kind of manually. I mean, not manually, but we set the split point manually based on a specific time point, because we don't want to use the future data to predict, old information, use future information to predict old results, right? So we split the data set considering time. But if random split is all you need, our Workbench provide that function already. Then let's get to the model part. First, we have summarized all the hyperparameters in this cell. You don't have to do that. You can set your hyperparameters anywhere, but just for clarity, we have all the hyperparameters here, and I will explain them when we get them. Now is the key part of the Workbench, right? Which are the data loaders. So that's also that's also the key benefit of using TigerGraph ML versus maybe a CSV file on your disk. So there are two important benefits, right? So first, TigerGraph is a proper graph database. You can store a large amount of data inside database, but you can only hold a small, if you want to load a graph into a memory, right? If you want to use in-memory, your own computer memory to store your graph, then that's just constrained by your memory. For a database, besides the size, it offers you, a way to manage your data. So that's number one. The second benefit is that our database is also a compute engine. So it can do things like sampling very efficiently. And then when you are getting data from database, you're not getting the whole data set or the whole graph, right? Imagine you have 10 terabytes of data. You don't want to dump all that data to your local computer and do your model on it. That will just crash your network. So what we do is that we will get a stream of subgraphs, right? Small bites of the data that you can digest, or your computer can digest. And also that has its own besides the computational benefit, it also has a theoretical benefit, right? So normally when you train your model, you want to do it in a stochastic gradient descent way, and then you want to do that in a mini batch style, then do your model on the whole data set. That might just result in overfitting or instability. So with this, right, so we provide you different data loaders. So here I'm going to show you neighbor loader. So what the neighbor loader does is that it will first, as I just said, sample subgraphs from the database, and then it will, then you will get a stream of subgraphs using this data loader. All right, so with all those words, let's see how it works actually. So what you need, right, is to construct this data loader, and of course you need to tell it, what's the TigerGraph object you're going to pull data from, and then you want to tell it the input features you want for your graph neural network model. So here the input features are all attributes in your graph database, right? And here we have specified, I think, 7 node features, and of course you can give it as many as you want or as little as you want. Then it's the output labels, right, or the ground truth of the predictions, and that's another attribute in your graph database. So those 2 things I think are the most important parameters to this data loader, right? What are your input data and what are your output labels? And then if you need some other data to help you, to help with your task, then they are all lumped together into this extra features argument. All right, then we, as I said earlier, we support both PyTorch geometric and DGL. So you're gonna tell it, what's the format you want. You want the final, want the subgraphs to be. Here I'm going to use PyG. And then the rest are, are sort of algorithm specific parameters, right? First one, batch size. As I said, you want to get, mini batches of data. So what's the batch size? You tell it. And then since this neighbor loader, maybe just a few words about what neighbor loader does. So the neighbor loader, right, starts from a few seed vertices, and then it collects the neighbors of those seed vertices and the neighbors of neighbors and so on. So that's how it samples a subgraph from this giant graph. And then the number of neighbors is, how many neighbors you want to collect for each seed node along the way. Number of hops, right, is how many steps you want to go out to get the neighbors to, to fill your neighborhood. With those, finally, just some common parameters. So filter by, you want your seed vertices to be in the training set, right? You don't want an information leak by accidentally getting things from the testing set as your seeds. So, you put the attribute as a filter. So here I'm going to give it the training set as the filter. And do you want to shuffle your vertices before before each iteration? Of course, we want it to be as random as possible to avoid any potential biases. So that's the data loader for getting the training data set. Similarly, it's very similar to construct the data loader for the validation data set. The only difference here is that you are filtering by the validation attribute, is validation attribute, not the training attribute. With that, so I would say, right, these 2 are probably new to most people for doing machine learning with TigerGraph, and the rest of this notebook are rather, are relatively straightforward or standard if you have done neural network before. So first, we create a model. We are going to use the standard, the built-in GAT model from the PyTorch geometric package. So you just call this GAT function and then give it all the model specifications. Right, that's how you construct the model. If you're using DGL, you can pull the DGL model from DGL package. The same, it works the same way. Then you construct the optimizer that will update the weights of your model after each iteration or each batch of training. So this is how to construct a neural network, or how to really set up the neural network. Right now, with the neural network, you want to train it. You want to actually you want to have it to be trained so that it can do something intelligent later. This is like a typical training loop. So first, right, we will go over the data set for 10 epochs. So each epoch corresponds to a complete sweep through the data set. We're going to do 10 epochs. And then within each epoch, here is what our data loader comes in handy, right? And here, what you can see is that you can just treat the data loader as a typical data loader that reads data from memory, right? So you just call the for loop, you iterate through this data loader, you will get subgraphs continuously. But behind the scene, this data loader will actually continuously pull subgraphs from the database. But we abstract away all that hard work. You don't need to know that unless you really care about it. You just need to call this data loader as normal. You will get batches of data here, subgraphs, like if they're in your memory. So you got the batch, you got the subgraph. Now it's something familiar to everyone, right? You do a forward pass through your model, then you calculate the loss of your prediction. With the loss, you do back propagation, so you get a gradients. Then you update your model so that it will learn from this batch. Okay, so I'm here, right? And then the rest of this this specific iteration is just logging and evaluation. So first, we want to calculate all those metrics, AUC, precision, recall, etc., on the training data set, right? We just want to know, if the training is doing anything good, if it's trained at all. Then this is, doing prediction on a training data set, and then a bunch of logging stuff. All right, logging is very important. We agree with you. After that, we're going to do a formal evaluation, right? So we're gonna evaluate the trained model after this batch on the training, on the whole, validation data set. And then in that case, you're not doing back propagation anymore, right? You're just doing a forward pass. You get all the metrics as before, and then you log them. All right, so I'm not going to run this cell. So actually, I'm not going to run this whole notebook because it will take some time, and I don't think we have time for that during this webinar. So I've already run this notebook right previously, and here is what the what the printout looks like. So you see, it will print out all the metrics. Of course, you're totally in control on what you want to print out. All right, and then in the end, you see, so finally, you see the validation AUC is superb. The validation precision is good. The validation area under the curve precision, area under the precision recall curve is, okay. Validation recall, not very good. But note, we haven't done any model tuning, right? We're just using default parameters, and we already get, I think, a great AUC. That's good news. With some tuning, right? With better, with more data on the labeling, on the labels, I think it's not, it's not impossible. It's not hard to improve the performance. Cool. So that's about the training of the model. And here, after the model is trained, we're going to use the GNN explainer built into the PyTorch geometric package to help us get some insights into the model predictions. Right? Basically, we want to understand why the model is making such predictions. I know this is not like full explanation, but I think those are valuable information to at least help us understand why. Right? And here, it's very easy to use the GNN explainer with a trained model. Right? You just call this explainer on the model, and then you use this explainer to explain any vertices or any prediction, the prediction on any vertices. And here I have, I pick a random one, and you can see that's what this explainer thinks is important for the prediction of those fraudulent accounts. Basically, it thinks that this kind of shape is important for identifying those fraudulent accounts. And it makes sense, right? When you see this kind of star shape and a lot of transaction going into this accounts, you should be careful, right? Those accounts might be collecting money in a short period of time for some suspicious reason. All right, and then you can also do common, feature importance calculations with that explainer. I'm going to skip the code. I just want to show you, right, what it looks like. So here, right, what you see is, feature importance, the importance score of each feature for predictions on each account or each node. Those scores doesn't really carry like a substantial meaning. I know some of you might have a question on, are they probabilities or something? I would say they're more like, just important scores. The higher, the more important. And here you can see the page rank score is the most important feature most of the time for the fraud detection task. And that makes sense, so because we have a transaction network, and the graph features, should really help. And then I also, just as a side information, I also plotted out or or generated the raw feature values, right? Just to show you how it's different than feature importance scores. And you can see, if you look at the raw values of the features, it's not the same as the feature importance. So the feature importance, I think, really capture some information about the importance itself. It's not just memorizing which feature has larger values. So this is trying to answer the question that is large scale features more important? Maybe, but at least in this example, we don't see that happen. Cool. So I think this is the end of this notebook and also this quick brief demo. I'm happy to answer any questions, but before that, Andrew, can you switch to the slides? And
Hey, Bill, 1 second. Actually, so there's a question from the audience about how GDPS is set up. So maybe you can briefly walk through it since you already have Workbench running on your laptop.
Oh, okay. Sure. Cool. Could you repeat the question?
Yeah, the question is, can you please explain more about how to set up the GDPS?
Oh, okay. So let me do this. Let me add a random server, right? And then this server doesn't exist, so it won't work in the end. But then you will see how it works, right? So all you need to do is to click this one-click installation button, and it will say, hey, I cannot find that service on your server. Would you like to install it? Of course, you want to say yes. And then it will ask a bunch of questions, right? Is the database running in a container or not? I would say yes, maybe. Okay. And then you will say, because in this particular case, right, because your database is running on container, it needs to know the hard drive, how you map the hard drive to the container so that you can read the files. So you need to give that information. I'm just going to give some random ones. But if it's not running on container, you'll get a different question. Then you just tell it, right, your SS username, your SS key to the database server and database username. Once you do that, it will install the GDPS onto that server. So that's the easiest way to set it up. You can also set up GDPS manually. We have documentation, official documentation on our official website. It's also not it's not like rocket science. All you need to do is to download our GDPS binary, right? And to your we have that for both Mac and Linux. You just download that binary to your server, run that binary with the right configurations. We have explanations on every configurations. You just need to run that binary, and then you're good to go.
Thanks, Bill. A follow-up question is, hey, hello, this may be a stupid question, but how do you get the GDPS panel in the notebook in the first place?
Oh, God, this thing, I thought.
Yeah.
I think that's what you mean. So
yes.
Yeah, this tiger icon, that's our JupyterLab extension. There are two ways to get that. So first, if you are actually, I think this connects very well to what I'm going to talk about next, which is how to get a Workbench. So maybe Andrew, you can share your slides, and I can talk over it.
Sure. Let me switch back here. Screen. Oh, you need to. Yeah. Thank you.
Cool. So yeah, so how to get you started, right? We have we have a few options, not to confuse you, but actually to make the starting process, onboarding process easier. So first, we provide a sandbox doc container. So if you are new to TigerGraph, or or you just want something you want to play with quickly, that might be the path we want to take. So that sandbox container contains the TigerGraph database, the GDPS service deployed, and also the JupyterLab pre-installed, and even the database pre-installed. So all you need to do is to run that container. And then you can go to the JupyterLab. Everything is installed. Welcome to play with it or within it. And then the second option, right, is the JupyterLab standalone installer. It's it's just a conda installer. So you download that installer, you run it as a bash script. Then you will have JupyterLab with all the Python packages installed on your laptop, on your machine. Then you start JupyterLab. You will have that TigerGraph extension pre-installed, right? And you will have our TigerGraph TGML package pre-installed. Basically, you have all the Python part pre-installed. You're ready to go. All you need to do is that you need to set up your own TigerGraph database, and then use that JupyterLab extension to deploy the service, the GDPS service, to your TigerGraph database. Okay, that's the second option. And the third option is when you have your own ML infrastructure. Not infrastructure, you have your own JupyterLab, right? So that's perfect, okay? We understand that. If you have your own JupyterLab, or if you are using Amazon SageMaker, if you are using Google Vertex AI, if you're using Azure ML, all you need to do is to pip install our JupyterLab extension and the TGML packages into your JupyterLab. It's if you have ever done that before, that will be very straightforward. Basically, you just open a terminal right within your JupyterLab, and inside the terminal you do pip install. I think it's called TigerGraph _ML Workbench. And then that will install that cute TigerGraph icon into your JupyterLab. And to install the TGML packages, etc., you just do pip install or conda install a file. So we have that all listed in our official documentation. And finally, if you're, if you like to mess with things like I do, you can do the manual setup, right? So first you can, as I said before, you can download the GDPS binary to your TigerGraph database server. You run that binary with the right configurations. So then that takes care of the GDPS setup. And then if you're not using JupyterLab at all, you don't, of course, you don't need that TigerGraph icon there. All you need is our Python packages, right? TGML. And then you can just pip install TGML into your own, Python development environment.
Cool. Andrew, did you want to take care of the next slide?
Sure. Okay. Oops. Cool. Thanks, Bill, for the great demo. I hope this session has been useful for the audience here today. Last but not the least, I just want to highlight our ecosystem support for ML Workbench. We're not just here to offer a product to our user. We are also interested in working with you to explore, what are the potentials of applying a GNN to solve business problems. And also, we are working on more demos or cooking recipes to build GNNs for different types of application internally. And we will publish those notebooks for our users. We also have a forum for dev community support. We welcome everyone to bring their discussions to our Discord channel. Please also don't forget to check out our YouTube channel. We make a new YouTube series showing several tutorials about how to set up ML Workbench or to various ways to create GNNs. So feel free to check them out. And then we have 2 minutes left. Maybe we can use it to answer questions.
Andrew, if you could skip forward a couple of slides, that might be helpful. Next one. One more. Yeah. So there's a lot of questions. I think we're almost out of time. We haven't answered all of the questions by any means. If people wanted to reach out directly to either Andrew or Bill, this is how you could do that. Also, you can, as Andrew just mentioned, feel free to join the community in our Discord channel. You can post questions. So that's that. Bill and Andrew, do you have time to stay on a couple of minutes later beyond the top of the hour, or do you both have to drop?
Sure, I can stay.
Okay, because we do have quite a few questions from the audience. So one of them was, I want to understand how flexible TigerGraph is. How do we define a custom random sampler, which is probabilistically sample subgraphs based on user-defined edge weights? I know this is possible in DGL, but I'm unclear on how to do the same in TigerGraph.
Bill, do you want to take this one?
Sure. I think, yeah, so I think there are actually two sides to this question, right? So technically, we're using GSQL to do the sampling. So that's very doable. So we are very flexible in terms of technology. So as long as you can write that as a GSQL, you can do it. All right. And then it's the business side. Andrew, do you want to speak to that?
I'm sorry, I think that the question was gone. What was the second part of the question? Something about the DG.
I mean, the question is about, can they implement their own sort of graph sampling technologies for the data loaders?
Yeah. Oh, yeah. It's we do have that flexibility. So if you want to have your own implementation of subgraph sampling, as Bill mentioned, it will be your implementation will be written in GSQL. Also, another thing I want to call out is in Bill's example, we are showing one type of graph sampling. Internally, we're also in the future release, we're also working on different sampling methods like graph sync.
All right, cool. Another question we had, is it possible to integrate TigerGraph with Spark? How? Question mark. Is it easy? Question mark.
integrate TigerGraph with Spark. So it depends on what kind of Spark tasks you want to do. So if you just want to pipe data from TigerGraph to Spark, we don't have like a native connector to do that. But then there are multiple ways, right? You can dump data to S3 and load S3 to Spark, or we are now working on a Kafka stream solution. So you can also read data, stream data from TigerGraph to a Kafka cluster, and then load from the Kafka cluster to a Spark cluster. There are ways to do that, but I don't think we have a. Maybe we do. I need to check, but I don't know if we can do that or not on top of my head.
All right, awesome. Hey, why don't we just do a couple more questions and then we'll wrap things up, because I know we're over time. Does that sound good, Andrew and Bill?
Sure.
Yeah.
So this came in a few minutes ago, and I know the person who asked is still on. So I'll ask the question, could you please review where your training set of positive examples of fraud came from? Were there flags in the data set? Did you insert them?
Yeah, so there are flags in the data set, right? In the raw data set, they basically, this is all historic data, so they know which accounts are bad accounts. But we also, I think we also crawled from some other services, some actual labels, but the majority of labels are already in the data set.
All right, cool, thanks. Final question. Do you have any recipes for multi-layer, in parentheses, multi-slice network analysis using multiple data sets?
Currently, no. So I guess I would like to know more, what kind of network analysis you are talking to, but we don't have that now. It's on our roadmap to support, like multi-graph neural networks.
Okay, awesome. All right, good. So I think we should wrap things up. We have 45 people still on the call. Thank you very much for staying on this long and over time. I know there were questions that were asked that we were not able to answer. Again, reach out to Andrew or Bill directly if you want an answer to those want them to answer you directly, or join our community. But I think we should, at this point, we should wrap up just in the interest of time. I want to thank Andrew. I know you have a bit of a cold right now, so thank you for soldiering through. You did a terrific job. Very impressed with your presentation. Thank you. Bill, again, terrific demo. Very impressed. And thank you for sharing your expertise with the audience.